So, in the previous lecture, we have discussed the three basic comparison sorting algorithms, double sort, selection sort, and insertion sort. And we have developed the pseudocode for algorithms, and we have analyzed the complexity of these three basic algorithms. Uh, Now, in this lecture, uh, we're going to discuss a different approach for sorting things, sorting algorithms, which and we have seen that three algorithm insertion sort, selection sort, and bubble sort have average case complexity order of n square. So we are going to discuss now a different approach which can reduce the complexity from order of n square to something less than that. We'll see what will be the less complexity. So the technique is called divide and conquer. From the name we can get that it solved the problem by dividing the problem and then conquering the regions. So this is basically the formal definition is that it is a paradigm for solving complex problem by breaking them into simpler subproblems. So, for example, if you have a list of 10 numbers, then at a glance you cannot uh, find the maximum number, or you cannot sort the 10 numbers at a glance. But if you divide the list into in a two numbers, if there is a sub list of two numbers, then at a glance you can sort the element. Like if you have like 2 and 5, then at a glance you can you say that it is already sorted 2 and 5. But if there is a list of 10 numbers, at a glance you cannot say that whether it is sorted or not. So from the 10 number problem, if you divide it into 5 numbers of sublist, then each sublist you can at a glance say that it is sorted or not. If it is not sorted, then you can rearrange it easily. Then you can combine this 5 sorted sublist into a sorted list of 10 numbers. So this is the actually basic technique of divide and conquer, that the three key step of divide and conquer is that split the problem into smaller and easier subproblems until it can be easily solvable. Then conquer and then solve the subproblems and combine it. Solve the subproblem recursively. That recursion, what is recursion, we will discuss later. For sake of simplicity, now say that conquer the result or combine the result or the solutions into of the subproblem to find the final result of the total the actual problem. So this divide and conquer technique we also use in our day-to-day life. In our day-to-day life, doing so in household things, in playing games, doing some clerical some desk task. I have used example in the previous previous lecture to where we have seen that the selection sort, insertion sort, and the box order used to sort the plates in the dinner tables, to arrange the plates in the dinner tables. So if there are some plates in the dinner tables are of different sizes. Like if you have a large stack of dinner plates of different sizes, which are in a random order, and you want to organize them, then you can sort them or arrange them by taking the largest plate, and then put it at the bottom. Then again, from the rest of the stack of plates, you take the second largest one and put it on the top of the largest one. Like that, you can do that. And this is the technique that selection sort will do. Otherwise, you can take two plates from there and sort it accordingly. Then take the third plate, then insert into the sorted two plate which you have previously sorted. Likewise, so this is the actually techniques used in insertion sort. So divide and conquer in real life. Also, what we used to do that we spread all the plates in the stacks one by one throughout the table, and then from single all the single plate we collect them and then combine them in a sorted manner and them. So this is the actually technique of divide and conquer. Just split the stack of plates into two smaller stacks or four smaller stacks, or repeat this process dividing process until it it become the single plate. Then you can compare the size of the plate and you arrange it properly. So this is the divide and conquer technique we also use in our day-to-day life. Also, we can if your teacher asks you to arrange the copy of the exam according to the its number or according to its roll number of the students. If the teacher asks to arrange them, then your friend can and say that I will help you. Then what you can do, two of your friends can divide the pile of copy into almost in the same numbers of copy into do a divide, and into differ separately sort the two pile and then merge the pile into single one, so that the final pile of the copy become sorted. So this is also the approach of divide and conquer we use in our day-to-day life. So we'll see in the next slide the example of divide and conquer, that is the mark sort. So how this mark sort work? We can take a simple example like this: that there is a number of list. There is a list of numbers of 8 elements: 5, 2, 4, 7, 1, 3, 2, and 6. Then what this mark sort is doing? It is doing that initially it is a list of length 8. It is dividing the input list in the middle position, and then 5, 2, 4, 7 it become a sublist, divided sublist, and 4, 3, 2, 6 it become the another sublist. Then again, the first sublist of length, it is divided into part of length 2, and the other part also divided into first part having 3, second part having the 2, 6. Then again, each sublist of length 2 is divided into two single elements. It's also divided into two single elements. 1, 3 also divided into 1, 3, and 6 also divided into 2, 6. Now, after this last stage of division, there are all are single elements. So now this all single element we can combine in a sorted way. So this blue section is a divide section. It is the divide section, and this yellow section is a conquer section. So after division completed, now we will conquer these elements, divided elements, into sorted. So how this is doing? It will take the first two divided element 5 and 2. If we want to sort it in ascending order, whether it is in ascending order or 5 is greater than the 2. So we will sort it like 2 and 5. So we form a sorted sublist of 2, 5. Then for 4 and 7, it will form 4 and 7 sorted sublist. Then from 1 and 3, it will form a 1, 3 sorted sublist. From 2 and 6, it will form a 2, 6 a sorted sublist. Then again, now it is combining the sorted sublist 2, 5 and sorted sublist 4, 7. Now, how will this? It will use the same technique what we have discussed in the insertion sort. That it will take the first element of second sublist, that is the 4, and it is try to insert into the sorted list of 5. That is the first subsorted sublist. So it will take the each element of second sorted sublist and it will insert into the first sorted sublist. How we have done in the insertion sort. Like this. So in the insertion sort, what we have done that the right hand side element is inserted into the sorted sublist of left side. So this is the technique what we have used. So this will be applied in this conquering process or merging process of the sorted sublist. So then 4 is less than 5, so it should be placed on the left of 5, and 4 is greater than 2, so it should be placed in the right of 2. So the final list will be 2, 4, 5. Then 7 is greater than 5, it is greater than 5, so 7 will be placed in the last. So this has become the sorted sublist 2, 4, 5, 7 after merging the two different sorted sublists 2, 5 and 4, 7. Similarly, from 1, 3 to 6, it will insert the 2 first into the 1, 3 and then insert the 6 into the 1, 3, 6. Then it will become 1, 2, 3, 6. This is the then 2, 4, 5, 7 and 1, 2, 3, 6. These are two different sorted sublists. Again, this 1, 2, 3, 6. This is element of 1, 2, 3, 6. That right sorted sublist. Each element of right sublist will insert into the sorted left sorted sublist, and then finally it will form the final sorted list. And it is 1, 2, 2, 3, 4, 5, 6, 7. So it is the sorted list. So like using these basic steps, merge sort, what is it is doing? It initially use the divide process, dividing the list into probably equal part, and until it divided into single element, then each single element is combined to form sorted sublist. Then each sorted sublist is combined to form larger sorted sublist, and then finally it combined or merge a sorted list. So this is that is why this is called the merge sort. So this is a very good example of divide and conquer approach, the merge sort. And there is another sort, which is sorting technique, which is quick sort. We'll see that what is the difference in the quick sort. What is different? What is different from merge sort, the quick sort? So from this simple example, we can step by step what is this quick sort is doing and why this name is quick sort. So after checking the step by step procedure, we'll see why this name is and what is the difference between quick sort and merge sort. So here also a unsorted list of here is 9 minus 3, 5, 2, 6, 8 minus 6, 1, 3. unsorted list of 9 elements. So this is a 9 elements unsorted list. Then how this makes sort of divide this list into sublist. It will not divide in the middle. It will not divide according to the position of the element or the length of the list. But what it will do? It will select a element from the list that is called the pivot element. There it is selected on the A list, but there is no order this rule that you have to select from last of the element, last of the list. You can select any one of the elements from the list, or in some other manner. For this, that how pivot elements should select for best performance in quicksort. So now for this example, say the last element, always the last element is selected as pivot element. So here 3 is selected as pivot element. Now the list will be divided like that. Each element from left, it will traverse the list, and each element each element of the list will check with the pivot element, and the less than numbers than the pivot element will be placed in the left hand side list, and pivot element will be placed in the middle, and the greater than elements or maximum elements or larger elements than 3 then the pivot element will be placed in the right hand side. So here first element is 9. Whether 9 is greater than 3 or less than 3, it is greater than 3. So 9 is placed here in again the second element is the 3. 3 is less than minus 3, minus 3 is less than 3, so it is placed in the left side of the left sublist. Then again there is 5, placed in right sublist. Then there is 2 is placed in left sublist. Then there is 6 is greater than 3, it is placed in right sublist. Then 8 is in the right sublist greater than 3, minus 6 less than 3 is in left sublist. Then 1 is less than 3, it is placed in left sublist. So in this way, comparing with the pivot element, the list is divided into 3 parts. There is left sublist, which is less than all the elements are less than 2. Less than 2 pivot element 3, and there is pivot element in the middle. Then the right sublist, which is greater equal to the pivot element. And in the similar way, in the first this is the first divided sublist, where the last element 1 is declared as pivot element. Then comparing with 1, this there is the division of left sublist minus 3 and minus 6 greater than 1, and the 2 the right sublist greater than 1. Now this 1 and 2 becoming the single element, only this minus 3 and minus 6 is created. It is created by taking minus 6 as pivot element. Minus 6 is the pivot element, and minus 3 is greater than minus 6, it will be in the division. So now this is going to become single element. And similar way, comparing with the pivot element, get the 5, 6 single element, and then 8 and 9. Now what happened? Now see what is the difference with March sort. The basic difference was that in March sort the division was doing into the middle of the list, taking the middle of the list. But here the division is done by comparing, comparing with the pivot element, and then in the March sort, after division completed, there is a conquer, the merging of this element in sorted list. But here we can see that after the division of the list into single elements, all the elements are in sorted manner. So if we take the first element -6 is the least element, minimum element, then next greater than element -3, then 1, then 2, then 5, then 6, then 8, then 9. So after only the division, we already got the sorted elements. So just concatenating these elements one by one in the same order, we can get the sorted list like -6, -3, 1, 2, 5, 6, 8, and 9. So here we saw there is no need to merge the elements because after division the elements are already in sorted order. So this is also following the divide and conquer, but this conquering step is not not complex like in merge sort. There are also in merge sort. Our step needed for division, same number of steps needed for conquering or merging the elements. In the merge sort, we see that this is needed, but in the quick sort, they are only needed a division step, then conquering the single step, just merging the divided elements into the same order. Then we would get the sorted list. So this is the end of this lecture. In the next lecture, we will discuss the difference between technical difference between map sort and quick sort, and what is the complexity of merge sort and quick sort, and what are the difference in best case, worst case, and average case scenario. So in the next lecture, we will discuss all these things.